Hi, this is Hudson Valley QBA. This video will discuss annuities. And it's the first video on annuities. You can pause the video to get a copy of the handout. It will say handout for Unit 5, Chapter 4 and 5. You also should have a copy of your formula sheet, and you should go through the PowerPoints. I'm going to click over to the PC, left, and this is what the handout should look like. We're going to go through these definitions. It's 3 pages long. I also want you to have the formula sheet out. And this formula, if you notice here are the formulas for annuities, ordinary or deferred. They're synonymous, and here are the formulas. And this is my PowerPoint presentation. As I said, it's Unit 5. So let's look at the first slide. Ordinary annuities. Like any new topic, we will have a lot of definitions. Annuities. It's the deposit or withdrawals of equal amounts over equal periods of time. For example, if you have a car loan, you will pay $350 every month for 5 years to pay off your car. It's an equal amount you are paying. If you have a life insurance policy, your life insurance policy might require you to pay $200 every quarter. Savings accounts, credit card debt, and the New York State 529, which is a savings plan for your children's college or your college, tax-free. You can have the same amount withdrawn from your paycheck, whether it's monthly or every 2 weeks or twice a year or twice a month, to be deposited in a 529. So let's look at the example of mortgage on a home. You purchase a home. It's recorded in the county clerk's office. They record it in the county clerk's office because if you default on it, your creditors know where to find, where to put a lien on your home. The property is used as security. Over many, many years, you pay equal amounts per month. That includes principal and your compound interest for that property. Now, you may be paying $1,000 every month. However, the amount you pay towards principal and the amount you pay for interest will change within that payment every single payment. Little hard to understand, but we will do an Excel project to explain it further. We are going to concentrate for most of this unit on ordinary annuities. Ordinary annuities, the payment is at the end of the period. For example, when you buy a house, you move into the house on the 1st, your mortgage payment isn't due to the end of the month. Same with a car loan. You buy a car on the 1st of the month, your payment is not required till the end of the month. An example where you would pay at the beginning of the month, it's called an annuity due, and your rent. You have to pay your rent on the 1st of the month, and that covers the entire month. That payment's at the beginning of the month. Ordinary annuities, the payment's at the end of the pay period, whether it's month, quarter, semi-annually, or annually. There's 2 types of ordinary annuities. A contingent, and that has a beginning and end. Your mortgage, your car payment. After 5 years, there's no more payments. At the end of your mortgage, you own the house. There's no more payments. The other type of ordinary annuity is called a perpetuity. A perpetuity has a beginning date, but has no end date. An example of a perpetuity issues income from the principal, and the principal remains the same. The best and about the only example I can think of is college endowment fund. If you put $1,000 in a college and endowment fund today, at the end of 1 year, you'll have your principal of $1,000, but you might have $50 in interest. Only the $50 in interest will be paid out as perhaps a scholarship. The $1,000 remains for the next year to accumulate interest, so that $1,000 never changes. That's why there's no end date. The $1,000 stays in that account infinitely. So let's look at some of the definitions. I, interest per period, that's the same we've been doing all semester on compounded interest. N, number of payments. Again, same calculation for compound interest. Future, let's jump down to future value. Future value is the sum of all the payments valued at the end date. In the book, it's called S, or S sub N. The new variable is called payment. You'll see throughout my slides that payment, that is noted as PMT. In the book, they call it R. That's why it's in parentheses. But it's the dollar value of the periodic payment or the withdrawal. So what am I talking about, future value and payment? So let's say a mortgage. We buy the mortgage today at zero now. In 1 month, we make the first payment. In the second month, we make a second payment. The third month, we make a payment. And we'll do that N times. Typically, a mortgage is 30 years long, so N would be 360. Now, if we wanted to find the future value of all of these payments, 360 payments, we could find the future value of this first payment right here. Here's the first payment. Here's the future value of it. We'd have to add that to the future value of the second payment, the future value of the third payment, all the way up to 360 payments. Now, to do that would be cumbersome. So we have a formula for an ordinary annuity future value. We can find the future value of all of those payments right here. So it's payment times the quantity, 1 plus I raised to the n minus 1 divided by I. Now, you'll notice our new variable payment. Anytime you see that new variable payment, you will know it's an annuity. So let's look at our first example here. You put $100 in a New York State 529 account at the end of each year. The account pays 7% compounded annually. What amount is accumulated? So again, always write your givens. Your payment is 100. I is 7% divided by 1. N is 4 years times 1. To substitute it in our formula is right here, 100 times 1 plus 7% raised to the fourth minus 1 divided by 7%. I would like you to pause this to make sure you can get $443.99. I want to caution you, as you can observe from the formula sheet, the formulas can be quite complex. You need to understand order of operations in order to get those formulas correctly. It might not be, it's very difficult in PowerPoint to write these formulas. So you might want to review order of operations. Now, I put $100 in at the end of each year. What happens, or how about if I put $50 in semi-annually? So I put $50, $50, $50, 50, 50, 50, 50, and 50. It's accumulating interest or compounding interest, 7% semi-annually for 4 years. So I'm actually taking the exact same amount out of my pocket, but I'm just doing it semi-annually. So our payment now is 50. Our I is 0.07 divided by 2, and N is a total of 8 payments. I want you to pause the video, substitute it in the formula, and you should get $452.58. And often you'll hear me say, does the answer make sense? Yes, I'm putting the same amount out of pocket. However, I'm compounding my interest more often. So therefore, I should get slightly more than the $443.99, which I do. You deposit $1,095 at the end of each year for 20 years in an account that pays 5% annually. What is the future value or the accumulated amount? Again, your payment is $1,095, 5% divided by 1, 20 is our N, and we have $36,207.22. Here is a homework which I wish you would do. Now, sometimes we're given the future value. We know how much I want. Maybe I want to pay tuition in 2 years for college. So I want to know what payment, what do I have to deposit today in order to get a future amount. So on your formula sheet, we have this payment formula given the future value. And I'll let you pause and confirm those results. In this slide, we are going to put $100 in the bank at the end of each year. 7% compounded annually, it accumulates $443.99. How many payments did you make? You'll notice we're using under ordinary annuity N equals. Given, I gave you a future value. You'll notice on the formula sheet there's more than one formula. I'm going to click over. If you notice here is a formula to find N, and here is a formula to find N. Why do I have two of them? Because in this one, future value is a given, and this one, present value is given. Remember that. So this time, I gave you a future value of $443.91, so you use this formula. Would like you again to pause, substitute it in, and confirm you can get N equals 4. Now let's do a semi-annual. I'm putting $83.97 in the bank semi-annually, so that's the payment. Again, here is a future value of $550. But this time I caution, make sure you calculate I and calculate, and we're looking for N. Since I gave you a future value of $550, you use the N formula that one of the givens is future value. You get N equals 6 total payments. But again, this is semi-annually. So therefore, you have to divide it by 2 and give it to me as 3 years. Never give me N equals 6. When you're looking for I, the nominal interest rate, you must do it by trial and error. Now, I gave you a formula for future value. In this, I gave you the future value, so we're looking for a future value formula where we're going to, by trial and error, find out what the interest rate is. I recommend you always start at 5%, go up by 1% or down by 1% until you reach the correct answer. So you need to do it by trial and error. Here is an example of compounding quarterly. You deposit $700 at the end of 3 months. Remember, 3 months is a quarter. In an account that pays 8% quarterly, how much will be accumulated in 10 years? So you need to calculate N, 4 quarters times 10 years, or N is 40. I is 8% divided by 4, or 2%. Your payment is $700, and we're looking for future value. So our answer is $42,281.39. Here's another homework. Ordinary annuities. I'm discussing section 4.2. And now present value or discounted. It's the sum of the monies at the beginning of the term that is equivalent to the sequence of payments. Present value. So if you had to make 3 more payments on your car payment, and you got a check from income tax check, and you wanted to pay off your car, you want to know what the present value of those 3 payments are. So we still have I, interest rate per period, and number of payments, payment. Now we have present value. We want to know the sum of all the present value. So maybe we have 3 more car payments, but we got some money from the IRS and we want to pay them off now. Note that the present value is at the beginning of the first payment. Okay? So we're looking for the present value of that payment, the present value of that payment, the present value of that, and we're going to add them up. So for ordinary annuities, where we're paying it at the end of the pay period, whether it's at the end of the month, the end of the quarter, or the end of the year, here are the formulas to find present value given the payment. Note there's a negative exponent here. Please be careful. Use the change sign key to compensate for this negative exponent. To find the payment when you're given present value, we use this formula. Again, negative exponent. To find N, the total number of periods given present value, note the entire equation has a negative sign on the outside. However, when you're looking for interest per period, again, you have to calculate by trial and error. So let's look at a problem where we're looking for present value. You plan to put $100 in an account at the end of each of 4 years. The account pays 7% compounded annually. What is the present value of the payments? 100 is your payment. -4 is the total number of payments, 7% your interest. So you could put $338.72 in the account today, and that would be the present value of $100 in the account at the end of each of 4 years. So look at this extra question. You plan to put $100 in an account at the end of each month for 4 years to pay for a car. Okay, let's say you're in college and you are going to put $100 in an account at the end of each month. So when you graduate from a 4-year school, you want to have money for a car, but what is the present value of that? The account pays 7% compounded monthly. How much can you afford for if the car is purchased today? 100 is your payment. N is 48. I is 7% divided by 12. Today's value of those $100 payments is $4,176.02. You plan to put $50 into account semi-annually for 4 years. The account pays 7% semi-annually. What is the present value? You need to find I. You need to calculate N and identify your payment of $50. So that present value is your payment. 7% divided by 2 is I. Don't forget your negative exponent. It's $343.70. Would like you to find the future value of that $50 payment for 40 years. And your answer, I want you to pause it. Your answer should be $452.58. I am going to stop the video here, and I'm going to stop the video here on slide 18, and I will do the second half of annuities in another video.